Yesterday we talked about how to decide if a single replacement reaction will work or not, whether it'll actually react, and for that you use the activity series. Double replacement you can also predict if it works or not, but you're going to use something completely different. For a double replacement reaction to occur, one of the products has to be either a gas, liquid water, so you'll actually see H2O, or a precipitate, which remember is a fancy way to say a solid. So you have to get either a gas, liquid, or a solid. If all of your products are aqueous, meaning that they're soluble, the reaction will not occur. So as long as you get at least one thing that's not aqueous, it will occur. And to figure this out, you're going to use the solubility rules, which are in your reference packet. It's on the same page as the formulas, and it's in the top right corner. So you'll need your reference packet for this. On your reference packet, under the solubility rules, where you see the word soluble, I want you to write aqueous next to that. And where you see insoluble, I want you to write solid. So sol means to dissolve. Able means able. So soluble means able to dissolve, which means aqueous. In means not. So insoluble means not able to dissolve, which means it's going to stay together as a solid. So this is what the solubility rules look like. Anything that falls into the soluble category will be aqueous. Anything that's insoluble would be a solid. So if you get two soluble things, two that are both aqueous as your products, that's when a double replacement reaction doesn't work. You do have to be careful because there are some exceptions. For example, if we look at bromides right here, it says all bromides, so anything that has bromine in it, will be soluble, but then if you keep reading, you see where it says except silver, lead, and mercury. So if bromine is bonded to silver, if it's bonded to lead, or if it's bonded to mercury, it fits the exception and bumps it into the other category. So again, if it fits the exception, it goes into the other category. So for each of these, the first thing you'll have to do is put your charges. And actually I want you to do the second one first. So I'm going to talk you through it, and I can't actually write on the screen, so you're just going to have to listen and see if you can follow along. So starting with the second one, K is a +1 charge. SO4 you could look up on your polyatomic ions, it's -2. Calcium is +2, and chlorine is -1. The next thing you're going to do is switch the partners, but you need to keep it +-+-. So K is positive, it's going to bond with the other negative. So you're going to put it with chlorine, but be careful not to take these 2's with you. You only take it if it's part of a polyatomic ion. So the 4 right here does belong to the SO4, so you will take that with you. So K and Cl are going to be bonded over here. Don't forget to recross your charges. So K is +1, Cl is -1, crisscross those down. Then you're going to take the other two. Calcium is +2, sulfate is -2, and stick those together, but make sure you write the positive one first. So it's going to be CaSO4. Recross your charges, but again it's +2, -2, so those two are going to cancel out as well. Then you need to look only on the right side of the arrow. So we are done with these two for right now. Don't worry about these two right now. And we need to see if it's going to react. So what you're going to do is look at the second half of each of your compounds. So for the KCl, the second half is the Cl. And that means it's a chloride. So if you look over here at our list, the second bullet says all chlorides are soluble except silver, lead, and mercury. So see if your chlorine is bonded to silver, lead, or mercury, which it's not. It's bonded to potassium. So it stays here in this group, and it is aqueous, which is what soluble means. So next to it, you're going to put AQ in parentheses. Then we're going to do the other product. So we have CaSO4. You look at the second half of it. So look at the SO4, and you're going to find sulfates on your list. And it's right down here, the fourth bullet. It says all sulfates except calcium, which this one is bonded to. So if it fits the exception, it bumps it into the other category, and that means it is a solid. So next to CaSO4, put S in parentheses. This reaction will occur because of your two products, one of them was a solid. So as long as you don't get AQ, it will work. AQ means it's a DNR, which stands for does not react. And the last thing is we forgot to balance it, so let's go back and do that. Looks like you have 2 Cl's and 2 K's, so you just need to put a coefficient of 2 in front of your KCl on this side. The only other thing to mention, and you can try some of these on your own and come see me at lunch if you need help, but if you end up with H bonding with OH, you need to recognize that what it's really forming is water, which will be a liquid. So water, you're not going to look up over here. It's always going to be a liquid, which means anytime you get HOH, it will react. And I would encourage you to leave it written as HOH over here because it'll be easier for you to balance it since the H is separate from the OH on this side. But you just need to recognize that it is water. And the worksheet that goes along with this is page 8. So if you feel comfortable, go ahead and try some on page 8 and try a few more of these, and then come see me for the answers and let me walk through it with you in person because it's kind of hard to show this on the screen. And that is all for today.